Today we're going to be working on lesson 19, which is found on page 94 of your text. In this lesson, we're going to be talking about factors and also prime numbers. Let's go ahead and get started. Now in lesson 19, we're going to be talking about factors, and we're going to learn a new definition of the word factor. We have learned that if we multiply two numbers together to get a product, that these two numbers are called factors. Well, notice also that since 3, 4, and 12 form a fact family, that 12 divided by 3 is 4, and that 12 divided by 4 is 3. Well, that gives us another definition of factors. The factors of a given number are the whole numbers that divide the given number without a remainder. Now, either way you want to look at a factor, it's correct. Either factors are the numbers multiplying together to give you a product, or if we take the product, make that the dividend of a division problem, the factors become the whole numbers that divide without leaving a remainder. So let's look at example number 1. In example number 1, we're asked, what are the factors of 10? Well, the factors of 10, to list those, we want to consider pairs of numbers which multiply to give us 10. For instance, 1 times 10 is 10, and 2 times 5 are 10. Now, there are not any other whole number pairs that multiply to give us 10. So our factors are 1, 2, 5, and 10. And you'll want to list these in order. Now notice that when the factors are listed in order, 2 times 5 is 10, and 1 times 10 is 10. The factor pairs will be coming in toward each other, like 1 times 10 is 10, 2 times 5 is 10. And this is helpful for when we list out factors of a given number. So look at example 2. We want the factors of 12. Well, think of the pairs. 1 times 12 is 12. Then 2 times 6 is also 12. And then 3 times 4 is also 12. But let's list these out using division. We know that 1 is a factor of 12, so 1 times 12 is 12. 2 is a factor of 12 because 2 times 6 is 12. 3 is a factor of 12 because 3 times 4 is 12. So when I make my list, I can make my list without even worrying about writing out the pairs by saying 1 times 12, 2 times 6, 3 times 4. And notice that my numbers are going in order. So let's consider another number. And this is not written in your book. I just want you to try to get the idea of this. Let's say that I wanted to write out the factors of 24. Well, if I wanted to write out the factors of 24, then what I could do is I could say, well, 1 times 24 is going to be 24. And then I would go to the next number, 2. 2 is a factor of 24 because 2 times 12 is 24. 3 is a factor of 24 because 3 times 8 is 24. 4 is a factor of 24 because 4 times 6 is 24. 5 is not a factor of 24, but 6 is. But notice how I already have 6 listed. Well, once I get to a number that's listed in these back pairs, then I'm done. I don't have to consider any other numbers. And these are the factors of 24. And this is an easy way of writing out the factors. Now, if you didn't like this way, what you could do is say, well, what are pairs of numbers that give me 24? And I could say, well, 1 times 24, 2 times 12, and you could list them this way and then rewrite them in this order. Either method is correct. Now, let's consider the numbers 1 through 10 and their factors. The number 1 only has one factor, that's 1. The number 2 has 2 factors, 1 and 2. The number 3 has 2 factors, 1 and 3. The number 4 has 3 factors. 1 is a factor. 2 times 2 is 4, that's a factor, and 4. 1 times 4 is 4. 2 times 2 is 4. The number 5 only has 2 factors, 1 and 5. The number 6 has 4 factors. 1 times 6 is 6, and 2 times 3 is 6. The number 7 has 2 factors, 1 and 7. The number 8 has 4 factors. 1 times 8 is 8, and also 2 times 4. 9 has 3 factors. 1 times 9 is 9, and then 3 times 3. And then the number 10 has got 4 factors as well. 1 times 10 is 10, and 2 times 5. Now, look at the factors here. 1 has only 1 factor, but look at the factors which have 2 factors. Or look at the numbers, rather, that have 2 factors. 2, 3, 5, 7, not 9, I almost circled 9. These numbers which have 2 factors are called prime numbers. Prime numbers have 2 factors. They have 1 and the number itself. So these numbers which have 2 factors are called prime numbers. Now look at your even numbers other than the number 2. The number 4, 6, 8, and 10. What do all of those numbers have in common? Well, notice that all of those numbers have got 2 as a factor. All even numbers will always have 2 as a factor. So that means that other than the number 2, all other even numbers will never be prime, because they're always going to have the number 2 as a factor, which means that they're always going to have at least 3 factors. Okay, so keep that in mind for our next problem. Okay, so let's look at example 3. Example 3 says, the first 4 prime numbers are 2, 3, 5, and 7. We looked at that here. Our first 4 prime numbers were 2, 3, 5, and 7. What are the next 4 prime numbers? Well, let's start with the number 8, 9, 10, and then number up to 20. And then let's consider numbers that are prime. 17, 18, 19, 20. Well, now remember what I told you about even numbers. Even numbers will always have 2 as a factor. So that means that 8, 10, 12, we forgot 13 in here, 14, 16, 18, and 20, none of those numbers will be prime because they all have a factor of 2. Now, 9 rather has a factor of 1 and 9, but also 3 because 3 times 3 is 9. 15 also has a factor of 3 because 3 times 5 is 15. So that means that 9 and 15 are not prime either. Does 11 have any other factors besides 1 and 11? No. 13 only has factors of 1 and 13. 17 only has factors of 1 and 13, or 1 and 17 rather. And 19 only has factors of 1 and 19. So these 4 numbers are prime, and they are our next 4 prime numbers. So 11, 13, 17, and 19 would be the next 4 prime numbers. Each of these numbers only have 2 factors, 1 and the number itself. Therefore, they are prime. Now, there's an activity in your book that I strongly recommend that you do, and it is on prime numbers. So you might want to work through that activity before you work through your practice problems. After you've worked your practice problems, come back and we're going to be going over those problems together. Now, you may be asking me, why do I have to know when a number is prime? Why is that important? Well, we use this idea of prime numbers a lot in upper level mathematics. As a matter of fact, it's a very important concept. The idea that a number can be prime, that is, it can only have 2 factors, or it only has 2 factors, the number 1 and the number itself. So it's a very important concept to understand, this idea of what we call prime numbers. So just hold on. We're going to be using prime numbers in later lessons. Well, let's go ahead and try your practice problems and see how you did. Okay, practice problem A says list the factors of the following numbers, and we have the number 14. Well, 14 is 1 times 14, or it's 2 times 7. So the factors would be 1, 2, 7, and 14. The number 15, well, let's do this the way that I did some of the others. 1 times 15 is 15. 2 is not a factor of 15 because 15 is odd. 3 is a factor of 15 because 3 times 5 is 15. 4 is not a factor of 15. 5 is a factor of 15 because 5 times 3 is 15. So that completes our list. And these are the 4 factors of 15. C, 16. Well, again, let's do it like we worked this one. 1 times 16 is 16. 2 times 8 is 16. 3 is not a factor of 16, but 4 is. 4 times 4 is 16. Well, if we have a number that is what we call a square, that is 4 times 4 is 16, and we put down 1 4, we are automatically done. There are no other factors of this number if you're doing it using this method I've shown you. We learned that 17 was prime, so 17 only has 2 factors, 1 and 17. Let's look at problem E. In problem E, we're given 3 numbers, and we're asked which number in each group is a prime number. So 21, 23, and 25. Well, 21, 7 times 3 is 21, so that automatically eliminates 21 from being prime. And 5 times 5 is 25, so therefore 25 cannot be prime. That means 23 is the prime number. And it is a prime number. Okay, 24, problem F, 31, 32, 33. Well, 32, 8 times 4 is 32, so that eliminates 32. 33 is 3 times 11. But 31, there's only 2 factors for 31, and that is 1 and 31. So 31 is prime. Problem G, 43, 44, 45. Well, remember that even numbers are never prime, so that eliminates 44. 45 is 9 times 5. 43 is prime. 43 only has factors of 1 and 43. Problem H. Which number in each group is not a prime number? So 41, 42, and 43. Well, even numbers are never prime, so that means that 42 is not a prime number. Problem H, 31, 41, 51. Well, a lot of times when you're looking at 51, you don't recognize that 3 times 17 is 51. But consider the number 51. 5 plus 1 is 6, and 6 divided by 3 is 2. You may have learned in previous courses that this is the divisibility test for the number 3. If we add the digits together, if the number that we get can be divided by 3, then that means that this number, 51, can be divided by 3. And 51 divided by 3 is 17. So then this 51 right here is not prime. So 51 is not prime. By the way, we're going to be working with divisibility later, and we're going to be going over this rule again. So if you don't remember this rule, then we'll be talking about it again in later lessons. Okay, let's look at problem J. 23, 33, 43. Well, 33 is 3 times 11, so that means that 33 is not prime. Now, let's look at K and L. Problem K, prime numbers can be multiplied to make whole numbers that are not prime. For example, 2 times 2 times 3 equals 12, and 3 times 5 equals 15. Neither 12 nor 15 are prime. Show which prime numbers we multiply to make these products. Well, let's think about the number 16. The number 16 can be divided by 2 to give us 8. So we know that 2 times 8 is 16. 2 is prime, but 8 is not prime. So let's think about the number 8. 8 divided by 2 is 4. So we know then that 2 times 4 is 8. So I can replace the 8 with 2 times 4. Now these two are prime, but 4 is not prime. But 4 is the same thing as 2 times 2. So I can replace 4 with 2 times 2. Now, 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So 2 times 2 times 2 times 2 are the prime numbers which multiply to give us the product of 16. Now you may have done this before, and the method that you use is called a factor tree. So let's go over it now. If I have the number 16 and I wanted to write out what is called the prime factorization of the number, then what I can do is use a tree. And the tree just helps me diagram what I just showed you. 8 times 2 is 16. Now 2 is prime, but 8 is not. So I'm going to take 8 and use two other numbers to multiply to give me 8. Well, 2 times 4 is 8. 2 is prime, but the 4 is not prime. Notice how I circle prime numbers as I go. Now 2 times 2 is 4. Now both of these are prime. Then I just record the numbers that I have circled. 2 times 2 times 2 times 2 is 16. Okay, so let's try L. In problem L, you have the numbers 18, or the number 18. So what I want to do is have a pair of numbers other than 1, I don't want to use 1 whenever I do this, that multiply to give me 18. Well, 9 times 2 is 18. 2 is a prime number. 2 can only be found by multiplying 2 times 1. So I circle it, I'm going to leave it alone. 9 is 3 times 3. Both of these are prime. So I can say then that 3 times 3 times 2 is going to equal 18. Now normally when we write our answers, we want to put our numbers in numerical order. So I'm going to put the 2 first. And then notice that in your solutions manual, they're going to use a dot instead of the multiplication symbol. So they're going to write their answer like this. 2 times 3 times 3 is equal to 18. So we're using what is called a factor tree to write out the prime numbers that multiply together to give me 18. You know, we're going to be talking about that later on also in your course. So if you don't really understand how the factor tree came about, we'll be talking about it again. Well, I hope you have a wonderful day and enjoy your math, and I'll see you tomorrow.